Welcome to Simple Concepts by DJ. Today we are going to see another important derivation that is based on nodal analysis. Okay, so this nodal analysis is used for complicated circuits where parallel circuits are being concerned, complicated networks where parallel circuits are being concerned. So in that only we are using this nodal analysis. So let's examine a circuit diagram and we'll see how many equations we can frame out of it. Okay, so this is nodal analysis. In this nodal analysis, I am considering four different resistors which is being connected in series. So I am drawing four resistors. This is R1, this is R2, this is R3, this is R4. So four resistances are being connected in series and I am going to name the resistors as R1, this one is R2, R3 and R4. R4 I had named it. Now what I'm going to do is here I'm considering a point here and I am connecting a resistor and I'm considering another junction point here such that these two junction points hold a resistor. This is another resistor. Okay, this is another resistor. So I'm going to, this is another resistor. Here these are two junctions have been formed here. Now from this junction I'm going to take another, I'm going to connect another resistor. Again from here I'm connecting another resistor. Again from here I'm connecting another resistor. A battery of EMF E1, a battery of EMF E1 is connected. A battery of EMF E1 is connected in this fashion. Okay. Similarly, another battery of EMF E2 is connected in this fashion, such that the positive terminal of the battery will be connected to the resistance R4. Here the positive terminal of this battery E1 will be connected to the resistance R1. Now, these three resistors, so R1, R2, R3, R4, this one is R5, this one is R6, this one is R7. So these three resistors are being combined such that they reach the datum node. They reach the point called as a datum node. They are connected to this datum node. From here, the branches are being grounded. They are being grounded. Similarly, the negative terminal of the battery is also connected to the datum terminal. And this negative terminal of this battery E2 is also connected to the datum terminal. This is how the circuit diagram looks like. Okay. So now we have R1, R2, R3, R4, R5, R6, R7, 7 resistors plus this one. Let us assume that the value of this resistor is R8. Okay, R8. So now what we need to do is we need to find the nodes. So I am assuming this, let this name of the node be A. Let the name of this node be B. And the name of this node be C. So the voltage that is being developed at this point A will be VA. The voltage that is being developed at this point will be VB. And similarly at C it will be VC. Right. So I'm calling this as node because node is a point in a circuit. Node is a point. It is a junction point in a circuit which consists of two or more elements. So this point should be connected to a branch where there are two or more elements. So in this, I'm considering A as a node because this A is being connected to branches 1, 2 and 3. So totally 3 elements are there. So our condition is we need 2 or more elements that need to be connected to this node A. So this is A is considered to be a node. Similarly, C is also considered to be a node because you have 3 elements that is being attached to C. Similarly, B is considered to be a node because there are three resistors are there. This is 4 resistors are there. 1, 2, 3 and 4. So this is more 2 or more. So it is more than 2. So it is B is considered to be a node. E1, E2 are batteries, right? So now what we are going to do is we need to find the we need to mark the direction of currents that is flowing through this circuit. So when let I1 be the current. let I1 be the current that is flowing from the positive terminal of this battery and passing through the resistor R1. This I1 will be bifurcated into three different types of current. So one current is I5, another current is I2, and another current is I8. This current is being divided the moment when it reaches this junction. Why it is being divided? Because these currents are following the law of parallel circuit. So in a parallel circuit, the current will be different, okay, but the voltage will be same. So you have n number of currents. So since you have three different branches, three different types of current is flowing across each branch, through each branch, okay. So this is I5, this is I2, and this is I8. Similarly, here in this I2 will go here and it meets the point at C. When it reaches the junction C, it is being divided into another current I6 which flows through the resistor R6, I6. Similarly, this is a current which flows, that is I3, flowing through the resistor R3. Similarly, you have this battery E2. This battery E2 is there. From the positive terminal, a current will flow through the resistor R4. So I am marking this current as I4. And this current that is flowing through R7 will be I7. So I have marked the value of the resistors and I have marked the direction of current. So now what we need to do is we need to solve the circuit. We need to derive the expression. So we have a formula called as n minus 1. So n is the number of nodes that is being involved in this resistive network. So how many nodes are there? We have node A, node B, node C, and this is called as a datum node. So altogether we have 4 nodes that is being involved in this resistive network. So n minus 1. So totally 4 nodes are there. 4 minus 1, which is equal to 3. So 3 different kind of equations can be framed from this derivation. By solving this derivation, we can find 3. We can design, or we can work out 3 different types of equations. So let's get started with that one. So what I'm going to do is I'm going to consider node A. Let us consider node A. This is node A. So in nodal analysis, we should use current law only. But as far as the loop current method is concerned, we can use the Kirchhoff's voltage law. Here voltage law will not function. So we need to use only the current law. So when I apply KCL, the Kirchhoff's current law at the point at the node A, I'll be getting an equation, that is the sum of current which is entering the junction is equal to sum of current which is moving out of the junction. So based on this law, I am framing an equation. That equation will be I1 minus I2 minus I5 minus I8 equal to 0. So I need to find the value of I1, I2, I5 and I8. So what is I1? I1 is nothing but E1 minus VA. VA is nothing but the voltage that is developed at the node A. So E1 minus VA, which is equal to E1 minus VA, E1 minus VA divided by R1. This is the value of I1. Similarly, the value of I2. I2 can be determined as I2 equal to, see, you have this I2 current flows to the resistor R2, which is being connected in between two nodes A and C. So since there are two nodes A and C are there, you will have two different type of voltages will be developed. So this I2, in order to find I2, the value of I2 will be the difference in potential between the two nodes A and C. So that will be VA minus VB, VA minus VC. VA minus VC divided by this resistor value, that is R2. Okay, this is nothing but I2. So we found the value of I2 here. So what will be the value of I5? The current I5 equal to, see, I5 is a current which is flowing through the resistor R5. So you have a voltage that is developed here, that is VA. So in this branch, you need to consider this branch from the point A till the datum point. So when you consider this point, you have a current, you have a resistor value, you have a voltage that is being developed across here. So what you need to do is, by Ohm's law, I phi is nothing but the ratio between the voltage and the resistance. So I phi is equal to VA divided by R phi. So this is the value of I phi. I phi is equal to VA divided by R phi. So what is I8? I8. So you need to find, because I8 is also a current which is moving out of the node, out of this junction A. So I8 is nothing but, see, this I8 flows from the node A through the resistor R8 and it reaches the node B. So you need to consider two different nodes, that is A and B. Here in these two nodes, two different types of voltages will be developed. So this voltage is the difference in this potential and this resistive value we need to take into account. We need to consider in order to find the value of I8. So I8 is nothing but VA minus VB. That is VA minus VB, because the current is flowing from the point A to the point B. So I am putting VA minus VB divided by R8, divided by R8. Okay, this is the value of I8. That is VA minus VB divided by R8. So finally we have arrived at the values of these individual currents. So what we need to do is, we need to substitute in this expression. So if I substitute, means I1, the value of I1 will be E1 minus VA divided by R1. E1 minus VA divided by R1, அது தட்டி விடாதீங்க, minus VA minus VC divided by R2 minus I5 minus VA divided by R5 minus I8 minus of VA minus VB, அது பாரு, இது பாரு, divided by R8 equal to 0. So VA minus VB divided by R8 equal to 0. Now what we are going to do is, now which implies E1 by R1 minus VA divided by R1, E1 by R1 minus VA by R1 minus VA divided by R2 plus VC divided by R2 minus VA divided by R5 minus VA divided by R8 plus VB divided by R8 equal to 0. So I have obtained this expression. So now what I am going to do is, I am going to combine all the node voltages at the point A, and I am going to combine all the node voltages at point B, similarly at point C, and I am going to work out this expression finally. So considering all the VAs, adding all the VAs, minus, putting minus here, VA outside, it will become 1 by R1 here plus 1 by R2 plus 1 by R5, 1 divided by R5 plus 1 divided by R8. Okay, so this is the value R1, R2, R5 and R8. Now considering, now we need to consider VB. How many VBs I have in this expression? I have only one VB. So plus VB in divided by R8. How many VCs I have? I have only one VC plus VC divided by R2 plus VC divided by R2. I have one E1 by R1 plus E1 divided by R1. E1 divided by R1 equal to 0. So I have, this is the expression here. So what I'm going to do is, I'm going to change the signs. If I change the sign, it will be VA into 1 by R1 plus 1 by R2 plus 1 divided by R5 plus 1 divided by R8. Now this positive will become negative, minus VB divided by R8. This positive will become negative, minus VC divided by R2. this positive will become negative as E1 minus E1 divided by R1 equal to 0. So this negative will become positive, 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 positive will become negative, negative, negative. So I have got this one. So I can also write this as, we know that this is R is resistance. So what is the conductance? The reciprocal of resistance is called as conductance. So if one R is the resistance means then conductance will be, if G is the conductance means it will be 1 divided by G is conductance. That is 1 by G is nothing but the, see if G is equal to, G equal to 1 by R. In this is the expression G equal to 1 by R, where R is considered to be the resistance value, G is considered to be the conductance value. So conductance is nothing but the reciprocal of resistance. So 1 by R is nothing but the conductance G. So instead of 1 by R, I can substitute it with G. So what I'm going to do is, this 1 by R will be converted into G. G is nothing but the conductance. So I can write this expression as VA into 1 by R1, 1 by R2, 1 by R5, 1 by R8 can be written as G1 plus G2, G1 plus G2 plus G5 plus G8, G5 plus G8. I can write this minus VB, VB into 1 by R8. 1 by R8 can be written as G8. VB into G8 minus VB G8 minus VC into R2 into G2 minus VC G2 minus E1 into G1 equal to 0. Minus E1 into G1 equal to 0. This is the final expression for this node A. Okay, this is the final expression for this node A. So now what we need to do is, now we need to find the node B. So we have obtained this equation, that is equation is, let us assume that equation is equation number 1. Okay, so now we need to find, we have found for node A, now we are going to find it for node B. Okay, for finding in node B, what we need to do? So for node B, so I'm going to apply KCL here. So when I apply KCL, it will be I3 plus I4, I3 plus I4, I3 plus I4 minus I7, I3 plus I4 plus I8 minus I7 is equal to 0. This is the KCL equation. Now I'm going to I3, I4, I8 minus I7. Now I'm going to find the value of I3. See, I3 can be written as VC minus VB. IC can be written as VC minus VB. So it will be I3 is nothing but VC minus VB divided by the resistor value, that is R3. Similarly, I4 can be written as E2 minus VB divided by R4. I8 can be written as VA minus VB divided by R8. Similarly, I7 can be written as VB divided by R7. So I have obtained the values for these current parameters. So now I'm going to substitute in this equation. So if I substitute, it will become VC minus VB divided by R3 plus I4 is E2 minus VB divided by R4. E2 minus VB divided by R4 plus I8. Plus I8 is VA minus VB divided by R8 minus I7. Minus I7 is VB divided by R7. Minus VB divided by R7 equal to 0. VC minus VB by R3. So this is the expression. Now I'm going to split the terms. So it will become VC divided by R3 minus VB by R3 plus E2 by R4 minus VB divided by R4 plus VA divided by R8 minus VB divided by R8 minus VB by R7. So this is the expression. So now what I'm going to do is I'm going to club all the things here. That is VB. I'm going to put all the VB here. Minus VB into minus VB 4, 8. So VB is VB into 1 by R3 plus 1 by R4 plus 1 by R7 plus 1 divided by R8. So I got the value of VB here. I have segregated all the VB terms here. I have a VC term. I have a VA term. VA term is plus VA divided by R8. I have a VA term. I have a VB term. I have a VC term plus VC by R3 plus VC divided by R3 plus VC by R3 plus E2 by R4 plus E2 divided by R4 equal to 0. So what I'm going to do is I'm going to change the signs here. So if I change the sign, it will be VB into 1 by R3 plus 1 by R4 changing the signs and putting it in the form of G. So it will be VB into 1 by R3 is a G3 plus G4 plus G7 plus G8. Okay, so this one will be minus VA into G8. VA G8 minus VC into G3 minus E2 into G4, that is equal to 0. So I have changed the sign. Negative value will take a positive value. Positive will be negative, negative, negative. So 1 by R3 is nothing but G3, G4, G7, G8 and VA into G8, VC G3, E2 G4 equal to 0. This is equation number 2. I have framed the equation number 2 here. So I am writing it over here. VB into G2, G3, G4, G3 plus G4 plus G7 plus G8, G7 plus G8 minus VAG8 minus VAG8 minus VCG3 minus VCG3 minus E2G4 minus E2G4 equal to 0. This is equation number 2. So I have formed a second equation. Now let us consider node B we have considered. Now we need to consider node C. Node C. How are we going to consider node C? Node C. So node C we need to find. So already we have 4 different types of nodes. 1, 2, 3, 4. So our equation will be getting 3 different type of equations. We'll be getting 3 different type of equations. So considering this VC will be node C. So node C. This will become node C. Okay. So node C. So I need to apply Kirchhoff's current law KCL at node C. If I apply KCL at node C, it will be I2 minus I3 minus I6 equal to 0. I2 minus I3 minus I6. Three different currents are being involved in this junction point C. So what is the value of I2? I2 is nothing but I2 is VA minus BC, VA minus BC, VA minus BC divided by R2. Similarly, I3 equal to I3 is BC minus BB, BC minus BB divided by R3. Similarly, I6 equal to VC by R6, BC divided by R6. This is I6. So substituting in this equation, I'll be getting VA minus BC divided by R2, that is for I2, minus VC minus VB divided by R3 minus I6. Minus I6 will be VC divided by R6, which is equal to 0. Now VA divided by R2 minus VC divided by R2 minus VC by R3 minus into minus plus VB by R3 minus VC by R6 equal to 0. So this is the expression I had found. So now taking the like terms, that is VA by R2. So we have VB, that is plus VB by R3, and we have three different terms, three different values of VC. So minus VC into 1 by R2, 1 by R2 plus 1 by R3, 1 divided by R3 plus 1 divided by R6, 1 divided by R6 equal to 0. So VA by R2 plus VB by R3 minus VC into 1 by R2 plus 1 by R3 plus 1 by R6 equal to 0. So now I am going to use the conductance method. So the third equation will be VA into R2 will be G2, VA G2 plus VB G3 plus VB into G3, VB minus VC into G2 plus G3 plus G6, G2 plus G3 plus G6, that will be equal to 0, that is equal to 0. So we got, this is the third equation. So we got three different types of equation where in a resistive network where four different nodes are being involved. So by this formula n minus 1, see we have four nodes, that is 4 minus 1. 4 minus 1 is 3. So totally 3 equations we need to get. So we have found 3 simultaneous equations that are being involved in this resistive network. So that is all about this. Thank you all for watching this video. Please do subscribe for more interesting and upcoming videos. Thank you.